Hey, welcome back to a very short math practice. At least that's the goal for this one. The only prerequisite for this is to be able to quickly find the midpoint. Episode 9 of this series was devoted to the concept and how I will quickly be doing this in my head, but I will talk about the math process and only write down the answer. And I do want to point out one thing about midpoint is that it's a very underused skill for many mathematicians in their quadratic exploration, but not for us. We will be using this skill a lot and applying it. All right, so like I said, let's take the average. If you're not interested in the concept, that's really what I'm doing. We're taking the average of these two endpoints. All right, so the average would be 8 minus 2 is 6, divided by 2 is 3. All right. Next one is, if you need to pause and take some time to do them yourself, go ahead and do that now and write them down somewhere. But let's check at this point. The average of 6 and 14 is 20 divided by 2, which is 10. And what's the average of this? This is 32 divided by 2 is x equals 16. And I'm writing them as x. Think of the x-axis. These are all horizontally aligned. So we're thinking of the x-axis. All right. What's the midpoint of these two x values? Negative 25 and negative 3 is negative 28 divided by 2. That's negative 14. And you can always check that there is 11 units to the right of this and 11 units to the left. All right. That's one way to check. It's not always the same number of units, but check that if you prefer. What's the average of negative 1 and 9? It is 8 divided by 2, which is x equals 4. What's the average of the next one? It is 6. What's the average here? It is 2. So check my work as well. And I'm giving you some time to do them in your head as well. All right, what's the average for the last one? I believe it's negative 4. Let's check that. Negative 4. I did negative 12 plus 4, which is negative 8, divided by 2 is negative 4. That checks. All right. So that's the main idea. If you're able to do this, you're going to be perfectly fine with the type of examples you will encounter in this course. And when do we apply that idea? Is to find the line of symmetry. Remember, that's one of my favorite components of a graph to label and highlight, which is not really part of the graph, but it helps us to sketch it very nicely. And the term that I want to introduce is axis of symmetry. The line of symmetry is the term that I like to use, which big books don't really use, but they call it the axis of symmetry, all right? However you like to think about it, it's the same idea, same concept. And really what you're gonna be encountering is an x value of 6, for example, and an x value of negative 4. Where is the line of symmetry? If you already know these two values, then just take the average, which would be x equals 6 minus 4 is 2, so x equals 1. Divided by 2 is 1. Okay. X equals 1 is the line of symmetry. Suppose we have a parabola, whether it concave, whether it curves upwards or whether it curves downwards, and we found the two x-intercepts. One of them is negative 2, the other one's 12. We can take the average to find that line of symmetry. What is that? It should be x equals 5. How do we get that? 10 minus 12 minus 2 is 10, and we divide that by 2 is 5. What's the average of the next one? 15 plus 5 is 20, so x equals 10. That is the line of symmetry, or the axis of symmetry. What's the next axis of symmetry? Let's take the average of these two. What is it? See if you can get it before I do. It is negative 4. How did we get that? Negative 11 plus 3 is negative 8. Divide that by 2 is negative 4. And notice how I wrote what looks like the same example. It has the same line of symmetry, but what is the difference? This one is curving upwards. This one's curving downwards, which is what I wanted to point out. It doesn't matter the curvature. The idea works the same. And the last one, what's the average of negative 8 and 20? I believe that's a 6. Check it and see. Let me know if I made a mistake. But that's one of the ways we're going to be applying it. And if you got this idea, we're ready to see how to apply this in future lessons. So hope you had fun with this and your understanding and speed is really good. So see you in the next few.